This video is going to talk about translation and probability. And there's two key things you need to translate when you're dealing with these questions. So if you see either of these words, and, or, you need to then think of multiplies. If you see and in probability, you got to think multiply. If you see or, you got to think addition. So if it's, say, a traffic light problem, if you've got to stop at the first traffic light and the second traffic light and the third traffic light, that would be a question where you'd multiply. If it was a chance if you stop at the first one or the second one or the third one, then you would have to add the probabilities. And so you got to start thinking that and get it in your head. As soon as you see and, you need to multiply the probabilities. If you see or, you need to add the probabilities. So let's say, for example, you are asked what is the probability of drawing a pencil or a highlighter out of your pencil case containing 26 pencils, 4 highlighters, 12 pens and 10 markers. So the key word is or. So you look at the pencils. So we have 26 pencils. So it's 26 out of 26 plus 4, which is 30, plus 12, which is 42, plus 10, which is 52. So it's 26 out of 52. There's no need to simplify the fraction. That's even easier to deal with than to know that you're right. The probability of a highlighter then, well, it's the same pencil case, so still 52 things, but there are 4 highlighters. So a pencil or a highlighter, so or is a key word, that means you will use plus. So it's 26 out of 52 plus 4 out of 52, which in the big fraction is 30 out of 52, and you could simplify that down to 15 out of 26. So that's a question where you were asked for or. If you were asked for a pencil and a highlighter, well, that would make sense, so that would be a possible. They are mutually exclusive. And the question then, if you were asked what is the probability of a mother delivering a boy and delivering on a Thursday, so again your key word is and, so that will tell you you need to multiply. So the probability of a boy is 1 out of 2, not maybe precisely, but rounding off. Girls are slightly more likely if you look at the world population. And then you have probability of a Thursday, well, that's 1 out of the 7 days of the week. So the probability of a boy and on a Thursday, so the key thing is and, so that will mean multiply. So the probability of a boy a half, probability of a Thursday 1/7, put those together, multiply, you get 1 out of 14. So now we're going to move on to a few more examples out of cards. So these are a bit more interesting and they're a bit more real world, but unfortunately the more interesting example you guess, the harder the question will tend to be. So this is even illustrated below. I'm dealing with 5-hand poker rather than Texas Hold'em or games where you can discard cards and pick them up. But again, simplifying down makes it really easier. So the best hand in poker, whether you know it or not, is a royal flush. So to get a royal flush, you have to get the 10, Jack, Queen, King and Ace, all of the same suits. So you got to get those 5 cards, all diamonds, all spades, all hearts, all clubs, whatever it is. So we're going to analyze this problem in some detail. So the first question is, what is the probability of a player being dealt a royal flush of spades? So it has to be those 5 cards, all of spades. So the player needs to be dealt this hand, but he can get it in any order. So you don't have to get it in that order. You get the king first, and then the jack, and then the ace, and then the 10, and then the queen, so they can come in any way. So for card 1, you have 5 out of 52. Because we're looking for one of these 5 cards of just of spades, one of the 4 suits, that's 5 out of 52. Once you get that card, well, now you have a slightly smaller deck. You have only 51 cards left, and you need to get one of the other 4 cards. So the second one is 4 out of 51, then 3 out of 50, 2 out of 49, and 1 out of 48, and that gives you this overall probability. So that's a very, very small chance. That's 1 out of 2,598,960. So there's a reason why it's the best hand in poker, because it's very hard to get. Then if we bring this on, what is the probability of a player being dealt a royal flush of any suit? So 10, Jack, Queen, King, Ace suited. So clubs, diamonds, hearts or spades. So for this, you could just take that probability and multiply it by 4. That should be the same thing. But this method is a good one. So with cards, it's often good to draw out your boxes. So you got your 5 different boxes. So for the first one, you can have any suit. So that gives you 20 cards. Where that 20 comes from is you have 5 cards of 4 suits, so that's your 20. Once you get that first card though, you have to then stick with that suit. So you go straight from 20 down to 4, then 3, then 2, then 1, and your deck as well is getting smaller. So that's a higher probability, but still very much a long shot. Question 3 then. What will be the chances of 2 players in a game both getting a royal flush? So when we look at this problem, you only ever focus on the cards that you know. So you don't deal with other players in the game or what's the chance that they have those. You always do your calculation with just the cold data. You don't take those other things into account. So for this first player, they're going to get the first 5 cards, and then the other player will get the next 5. It doesn't matter what order is dealt in, it's random. People just tend to deal around in a circle to help shuffling better, and then possibly to help people who are boxing the cards cheat a little bit too. So this first person, they have any suit. So they can have any of those 20 cards above. It's 10, Jack, Queen, King, Ace of any suit. Then they got a match, so it's the same as before, 4, 51, 3, 2, 1. Then that second person, they can't have that suit, obviously, so they start off with any of the other 3 suits, so 15. So then after they get one of those cards from one of those suits, you're again down to 4, 3, 2, and 1. And the deck is going down each time. So you can see this thing here. This is a huge probability. So that would be 1,000. That would be 1,000. That would be million. That would be billion. That would be trillion. So you have a 1 in a trillion chance. If that does happen, it's actually a tie in poker. There's not such a thing as a better suit. So you would just share the winnings half and half. So again, like I said there, that is just based on dealing 5 cards, no extra cards picked, and not Texas Hold'em or one of those styles. So all poker rankings and the strength of the hand, they're all based on probability. The reason the royal flush is the best because it has this tiny probability percentage of happening. The next rarest you can have is a straight flush. So that is running cards of the same suit, but it's just not this top one. The royal flush is a straight flush, but it's just the best one. So a straight flush could be 6, 7, 8, 9, 10 of clubs. So it's numbers that run along in a row, all of the same suit. The next rarest is 4 of a kind. So you have 4 threes or 4 queens or something like that. A full house is after that. That's 3 of one kind and 2 of another. A flush is all of the same suit. A straight is running cards, so just counting up. So 8, 9, 10, Jack, Queens, that would be a straight. 3 of a kind, 2 pair, and a pair. So they are all the different types of hands you can get, and you can see the percentages get bigger as the cards get weaker. So a straight would be 3 of a kind, 3 of a kind would be 2 pair, and so on. So the obvious question then is, what is your chance of getting a hand that isn't any of those things? So just 5 unmatching, not straight, unsuited hands. And a hand like that is known as a high card because that's all you have. If you have a queen high, that means you just have a high card, you don't have anything else with it. So this would actually be pretty difficult to calculate. I actually did the calculation for getting a pair, and it's trickier than I would have thought. So what you have to do is you can't just get 5 cards because you got to make sure that your cards don't match, so they're not pairs. They're also not straights, they're not of the same suit, so you got to take a lot of things into account. So it is a bit of a headache to calculate that if you go directly. So there's a lot to consider because it can't be any of those. It's probably more difficult than you think. But there is an easy way to do it. So remember back from our previous lesson on exhaustive studies. So the exhaustive studies, the all of events, so the total probabilities must all sub to 1. If you get 5 cards, it's got to be something. It must be a pair or 2 pair or a high card or a royal flush. It's got to be something. So if we switch our perspective and look at the chance of not getting any of those things from the table rather than getting the high card, the problem becomes a lot easier. So the probability of getting a high card, it's got to be something. So it's 1 minus all of those probabilities. Now the percentages in the tables, probability percentages, it's a similar thing, just multiply or divide by 100. So the probability for a high card, probably should have this as 100%, so just take a sec. So now we're dealing with percentages. So you have 100%, it's got to be something. You take away all of the individual percentages from above. So that's 100% minus this symbol is the sum of all of the above. So it's the 42.2596 plus the 4.73. So you add up all of those percentages, you see what they are. It's 100% minus those, and you'll end up that your chance of getting a high card is just very slightly more than half. So half the hands you get, all you would have would be a high card. So this technique here is a very useful trick anytime you're asked for something not to be the case. So as another example, what is the chance of throwing a dart and not hitting a bullseye? So to do this, you would have to do one of two methods. The first one is very long. It was so long I didn't even bother typing it out. But if you have a dartboard, for it not to be a bullseye, you have the probability of hitting the 1 segment, the 2 segment, the 3 segment, all the way up to the 20s. 20 is the highest number on a dartboard. So you have all of those probabilities plus hitting the outer bull, that's the green bit around the bullseye red bit. And then you'd also have the chance of hitting the board. And even I didn't think of a bounce out, so something not landing in the board. So you'd have to add up all of those probabilities to find the probability of getting the bullseye. The other way to do it, the alternative way, is you take away 1, which is certainty that something is going to happen, minus the probability you would hit the bullseye. So if your bullseye probability was something like 0.1, your probability of not hitting the bullseye would be 1 minus 0.1, so the probability would be 0.9. Whichever way you do it, you should get the same answer, but I think this second method is much easier and it's a much quicker one to use if you're doing a question. So that is our lesson for today. And again, key thing here is when you're dealing with some of these questions, anytime you see and, think multiply, and anytime you see or, think plus.